Hello everyone, I am Sunidhi Pandey and today we'll be delving into the fascinating world of natural language processing brought to you by Project Pro. So let's get started. So let's understand what is NLP, natural language processing. Okay, imagine teaching computers to talk like us. That's exactly what natural language processing or NLP is all about. NLP is like the magic behind Siri, Google Assistant, even those helpful chatbots you see on websites. It is the art of making computers understand and talk back to us in our own language. So it is a subfield of AI as we understood right here, and it helps us analyze, it helps us translate machines via machines, chatbots, and other things. Text messages, when we send someone text messages and our text automatically gets auto corrected thanks to NLP. Machine translation, NLP can turn English into French or any other language we want. Then we have chatbots and customer support. When we chat with any customer support online, it is often an NLP powered chatbot that is helping us. Then we have sentiment analysis. Social media NLP can detect if people are happy or angry in their post. We have something called speech recognition. Yes, voice assistants, Siri, Alexa, Google Assistant, they all chat with us using NLP. Then we have language generation. Summarizing news, search engines. Google can understand what we are searching for through NLP. Or NLP can also read tons of news and give us the conclusion of that news in just of seconds. So NLP is a really cool thing. We got that. But does it have any challenges? Let's see. So NLP has its own set of challenges as well, like ambiguity, variability, sarcasm and humor, data quality. Let's go through each of them one by one. What ambiguity? Language is inherently ambiguous and words can have multiple meanings depending on the context. Word can mean different things in different situations and NLP must figure out the right meaning. An apple can mean an apple company that we know about or an apple as a fruit. And NLP needs to know which apple we are talking about. Then here comes the point of variability. Different languages are over there, and because of different languages, different accent, different ways of writing anything, a language itself and multiple languages can vary over the region and stuff. And NLP models needs to overcome this specific challenge. Languages and accents. Then there comes sarcasm and humor. Sometimes we as humans are tricky with our own words, and NLP needs to get our humor. Then there comes the point of data quality. We cannot feed our NLP models anything we want. We need to feed it a quality data. It needs a lot of good data to learn from. So, what is the impact of NLP in our real life? See, NLP changes our life. How? It saves time. It helps us find information faster, type less, and talk more to our devices. Then it also helps in global communication. It improves communication. How? NLP breaks down the language barrier and it helps people connecting worldwide. Then it also is used in healthcare. Doctors use NLP to read and summarize patients' records. It is used in finance. It is used in entertainment. It is used highly in education. Teachers sometimes grade papers faster using NLP. So, in a nutshell, NLP is like teaching computers to chat with us, and it is doing some pretty amazing things across the globe. It is not perfect yet, but it's getting smarter every day. Now that we have looked over NLP, its challenges, and its impact, let's understand NLP technologies or technique, I should say. Let's move on to NLP technique. So, some really interesting NLP techniques are tokenization, named identity recognition, NER, sentiment analysis, text summarization, machine translation, topic modeling, word embeddings, and many. But these are the techniques that we are going to understand and learn today. So let's move on. The very first technique we're going to talk about is tokenization. What is tokenization? See, tokenization is the magic trick that helps computers understand the words we write or say. It is like breaking a sentence or a paragraph into smaller, more manageable pieces that are called tokens. So you can see a word natural language processing, let us take it as a string, is broken down into smaller parts like natural, language, and processing. So this is how we are breaking it down into multiple pieces. And we call these specific pieces tokens. Like if I say I love ice cream, it is I love ice and cream in different sections. It helps NLP models to understand and work with human language by breaking it down into manageable units. And how do we do that? Manually? No. We use libraries and tools that are already available to us to perform this task efficiently. Let's understand it more. So different types of tokenizations are word tokenization, sub-word tokenization, character tokenization, punctuation handling. Word tokenization is when we split text into words. How? Imagine taking a sentence like I love pizza and cutting it into separate word tokens. So you get I love pizza. It's like giving each word its own spotlight. Then we have sub-word tokenization. What we do is it's like breaking words into puzzle pieces. For instance, if you have the word unhappiness right here, the subword tokenization might split it into unhappiness or unhappiness as two. We can also break it down from here as unhappiness into three parts. This helps computers understand the meaning even when they haven't seen that exact word before. Even if we haven't sent or told the computer what unhappiness means, if he knows happiness, if he knows the meaning of when we apply in front of a word, it will understand what unhappiness means without even us telling it. See how cool it is. Then it is character tokenization is the next one. It treats every single letter as its own token. So hello would become HELLO. Then we have punctuation handling. Yes, special characters are separate tokens. It is a neat trick we can say. It makes sure even special characters like commas or exclamation marks they get their own tokens. So for hi there, it is hi there and there's an exclamation mark right here. It is like giving punctuation marks a stage to perform. Then we have tokenization libraries that we just discussed in the previous section. You know, all of this tokenization stuff is super important for computers. So some well-known tokenization libraries we know include is NLTK, Natural Language Toolkit, Sparsy, and the built-in tokenization that are found in deep learning frameworks like TensorFlow and PyTorch. These tools are like language processing experts for computers, ensuring that text is properly segmented into manageable units for further analysis and understanding. Let's move on. So, we have discussed tokenization. Let's look at some projects of tokenization. We will discuss everything related to projects about each and every techniques. So, Project Pro gives you an amazing tokenization based project named Build a Text Generator Model using Amazon SageMaker. This is the link you can go to, or you can just go to Project Pro, search your projects right here, and get this project. This project will be a star maker for your resume. It's a really needy project if you are actually working on NLP and want to work with tokenization especially. You will understand not just theory and basics of tokenization, you will actually work with such things. Let's move on. Next, we have named entity recognition, NER. This is such a cool thing. Let's understand what NER is. It is natural language processing based technique that involves identifying and classifying specific entities. Mind the word entities, such as names of people, places, organization, any location, date, etc. We can see in this example, if you're using the text, hi, my name is Aman Kharwal, we can understand or our NER will understand that Aman Kharwal is a person. I am from India. From India, it will understand that this is where we are talking about a location, GPE. Then I want to work with Google. It will understand this right here. Google is the organization we are talking about. Then again, Steve Jobs, using Steve Jobs in a line will make sure that this specific word is ensured as a person. So why it is used will we understand in the next section. So examples of name entities can be, as I said, names, it can be a place, it can be organization, it can also be date, like she was born on May 10, 1990. So NER would capture May 10, 1990 as a date. So any use cases of NER like information extraction, it is used for to extract information, like we're extracting that Sundar Pichai is a person, Google is an organization, Mountain View, California is a location, and then we are understanding the language that is spoken by us. Or then we'll use the same information for chatbots. Then it's also used for legal and compliance. It is like a compliant related task like identifying contract dates and names of involved parties, etc. Let's understand the real world applications of NER. So let's the very first thing is information extraction in news articles. In news articles, NER is a very valuable tool, in the news industry. It is automatically identifying the extracts and critical information like names of politicians, location of events, and dates from news articles. This makes it easier to categorize and summarize news stories efficiently. Next is financial and legal documents. NER is a crucial component in the finance sector for spotting entities such as company names, stock symbols, and financial figures, and in documents like annual reports. In legal context, we can say it helps in identifying essential information like relevant date, contact parties, legal terms in contracts, and agreements. Next, we have chatbots and virtual assistants. See, NER greatly enhances the performance of chatbots and virtual assistants. It accurately recognizes user requests, such as identifying dates for scheduling or appointments or extracting any location for providing directions. It does what we ask it to. Next, two other more examples are social media monitoring. Social media needs to be monitored. So NER is employed to monitor social media platforms like to mention the brands or events and recommendation systems as well. When the user reads an article mentioning space exploration and Elon Musk, NER can recognize these entities and recommend related articles on space exploration or news about Elon Musk's space ventures. So, these were some applications that were demonstrating how NER simplifies information extraction and enhances user experiences, aids decision making across various industries. Let's see some of NER techniques. So the two common techniques for named entity recognition NER is conditional random field CRF and word based model. We will look at them properly, but the conditional CRF are like NER detectives for NER. They use patterns and context to figure out if a word in a sentence is named entity, like a person's name or a place. Okay, so for example, imagine we have the sentence John visited New York. John visited New York. Now CRF look at not just John or New York alone, but also the words around them by considering the context. So they can tag John as a person's name and New York as a location. Next, we have word-based models. Now, what word-based model is? They are like language wizards. They read the entire sentence, understanding how each word relates to the others, and figure out which words are named entities. They are great at capturing complex relationships. For example, let's take the sentence Harry Potter, the famous wizard, lives in London. The bird-based model will analyze the entire sentence and noticing that Harry Potter is a person and wizard doesn't refer to a person and London is a location. They're like all-knowing readers. So these were some techniques that different superpowers we can say for NER, with CRFs focusing on patterns and local context, while bird-based model understand the big picture and relationship within a sentence to identify named entities accurately. Next, we have text summarization. It is an amazing technique and we can understand what it does. It summarizes the text. We are giving it a text, it will combine, it will split into sentences, then vectors, we'll see the similarity matrix, we'll get it, we'll create a graph, and from sentence ranking, we will summarize the entire text to a conclusion, we can say. So, text summarization plays a very significant and valuable role within the realm of NLP. To begin, let's delve into the concept of text summarization. So, imagine encountering an extensive text content, like any from article or magazine or social media, and we don't have that much time, so we want a nutshell report of that text. What we'll do, we can summarize our text in a few lines by removing unimportant text, and we can convert the same text into smaller semantic text form. Semantic, by saying semantic, we mean that the meaning of the text is not being changed. The meaning of the text will never be changed if we are converting it from a long text to a shorter text. The meaning will be same. Now it has two approaches. Let's look at them. The two approaches are extractive and abstractive. Let's understand these two approaches properly. So extractive approach, we summarize the text using simple methods. We use very simple and very traditional algorithms. So for example, we make a list of important words and how often they appear in a text. Then we pick the sentences that have these important words and use them for our summary. This way, the words in our summary are definitely in the original text. Then we have abstractive approach, which is used more. What abstractive approaches are? They are more advanced. They are an advanced version of extractive approach, and we're talking about abstractive approach. So they transform the sentences into shorter ones while maintaining the same meaning as the original text. That means semantic approaches of our text data. So let's understand both of them with more examples. So extractive summarization works this way. We have some text, this one, and we are trying to summarize it. So we'll take the important lines like this, these blue ones are important ones. We will feed the data, and when we have the important ones, we will combine them and we will give our summary. But abstractive one, it reads all of it. It is not dividing it into important and unimportant. It is using all of it and creating the summary of its own, a grammatically correct summary. Let's see with an example. So extractive summarization is like this. Peter and Elizabeth took a taxi to attend a night party in the city. So it is taking the important words like city, party, attend, and the name of the two people, Peter and Elizabeth. While in the party, Elizabeth, again that person mentioned again, collapsed and was rushed to the hospital. Now, how extractive summarization will do it? It will do it like this. Peter and Elizabeth attended party, city, Elizabeth rushed hospital. It is not made to create it grammatically correct. It is just giving us a conclusion based on how it is getting from the source text. With abstractive summarization, it is also mentioning the important words like Peter and Elizabeth and attend and party and Elizabeth hospital, but it is giving summary, a grammatically correct summary by its own. Like Elizabeth was hospitalized after attending a party with Peter. So this is how extractive and abstractive summarization works. For text summarization, Project Pro gives amazing uh, projects such as abstractive text summarization using transformers BART model. See, we have this amazing project that is based on text summarization. You will not just understand how text summarization works in the theory, you will actually work with them practically. You will create models, you will create a BART model that will use transformers and stuff. You will have such project outcomes. You will be fine tuning the BART model using transformers. You will actually understand how BART model works. You will be importing the data set. You will create your own model by splitting the data, training it, and fitting it. And you will also get your own architectural diagram below to understand how your model will work, from project preparation to actually how you will deploy it using Flask on a web application. You will get it all. You will get an architecture diagram. You will also get help from one-on-one live interactive sessions using Project Pro. And you can start your project whenever you want. Many people have been benefited from Project Pro, and you can be one of them. Having this abstractive text summarization using Transformers BART model in your resume can make your resume stand out between thousands. And if you want some more projects, you can just go on search projects, search text summarization, and you will get your more projects based on text summarization. So this can be your chance to make your resume shine. The next technique we have is machine translation, MT. So, in simple terms, machine translation is the process of converting the text in a source language to a required target language. So, in the pictorial representation right here, we can see that we are giving it any information here, and we are using the Google Translate, which actually uses the algorithm of MT, machine translation, and it is giving the output in this language, which is probably Chinese. So this is how machine translation works. So we give a sequence of text in a source language like English or any other language we prefer, and there is no single best translation that text to another language. There's no single best translation for a text to another language. That is because of the natural ambiguity and flexibility of human language, especially with most of the Indian languages that are rarely spoken in other countries. So let's understand some types of empty techniques. What are some really cool empty techniques? So statistical machine translation, rule-based machine translation, hybrid and neural are the techniques, and we will understand about them a little bit in our upcoming slides. So with statistical machine translation, we have something that is it is kind of like a machine translation paradigm where it is done on the basis of statistical models, the parameters of which are derived on the basis of analysis of large volumes of bilingual text corpus. Now, the word bilingual text corpus, it refers to the collection of large and structured set of text written in two different languages. So it is mostly based on IT logic. It is mostly based on IT logic, which studies the quantification and storage and communication of information. So how statistical machine translation these models are made? They are made using supervised and unsupervised machine learning algorithms both. So we give them a source or target text, like a parallel version of it, and we also give source text, and it is giving the output here like translation model. We using the translation and the language model, and we are then decoding the algorithm. So we are not just feeding it a source text, we're feeding it a parallel text as well. This is what we meant by giving it a corpus. Let's understand rule based machine translation. In rule-based machine translation (RBMT), these translation are built in on various sophisticated rules, I should say. We have built-in linguistic rules and millions of bilingual dictionaries. So what happens is it provides the user with the freedom to make use of their own terminology by adding them to the translation process. Now, this is done by creating a new user-defined dictionary that overrides the system's default settings. The given below example that we can see here will help us understand the basic concept that is involved in RBMP. So what we are doing is we are breaking down the sentence into three pieces. My name is Aditya Jain will give us this, and machine translation will give us this, and fascinates me will give us this. And we are using the proper English and Hindi rules that are already defined, breaking it into three pieces and combining it again and getting a grammatically correct output. How it is doing? We are doing it by the built-in linguistic rules and millions of bilingual dictionaries. We already have defined how to break sentences and how to match them again, and this is how it is using it. Next, we have hybrid machine translation in NLP. So, what happens in HMT is that it is a method of machine translation that incorporates the use of multiple different machine translation approaches within a single machine translation system. How does that work? The underlying motivation to use HMT is the fact that if a single system fails, if a single system fails, it will lead to failure of the entire system. It will lead to the failure of the entire system. So we are trying to get an approach where even if a single system fails, the entire system is still in a working condition. It requires some approaches like multi-engine, statistical rule generation, multi-pass, confidence-based, and this is how it works. Next, we have neural machine translation (NMT). In neural machine translation, we make use of neural network models. This is the highly and widely used machine model right there. In neural network model, what we do is it learns from a statistical model that we learned in the very first page, and it does the machine translation. So the key advantage of NMT over SMT is that a single system can be trained directly on the source as well as target text, so thereby removing the dependency on a pipeline of specialized system as that in SMT. So we can train our this neural machine translation model that is based on neural network. Uh, we can give it directly source text or the target text, and it will give us a proper result. So neural machine translation is the widely used translation technique that is used out there. So let's see examples of the companies that use it. So popular tools are Google Translate. It uses the technique, which technique? Neural machine translation, NMT, that we learned just before. I told you this is highly used technique. So if we are giving it an English sentence of hello, how are you, we are getting a French one which says bonjour and rest with very high accuracy. This specific model gives us high accuracy. This is one of the most highly used model out there. Then DeepL use the same technique NMT, and it's specifically a deep LSTM, long short term memory network. This is one of the most common words you will encounter while learning about ML and AI. So do mind it. So translating the English phrase the quick brown fox jumps over the lazy dog into German, it will give us the German translation, and it will maintain both accuracy and naturalness of the output. Then we have Microsoft Translator that is embedded in Microsoft Edge and stuff. So Microsoft Translator uses a combination of statistical and neural machine translation. It uses LMT as well, but at the same time it uses a combination of statistical and NMT both. So if you want to translate the English sentence, where is the nearest restaurant, to Spanish results in the Spanish language, and it will do this with good quality. The next technique we are going to understand is sentiment analysis. Sentiment analysis is like a text detective that figures out if a piece of writing is saying something good, bad or neutral about anything. So its job is to understand what people feel when they talk about something, and businesses use it to grow. It's not just about positive and negative. It's not just this. It is more than something. It can tell actually people if they are happy, sad, angry when they are writing something. So if we want an example, what it uses is NLP process algorithms such as rule based, automatic, and hybrid. So how it works is, for example, if we want to analyze whether there is any product, we have any product, and if it is satisfying to customer requirements, or if there is a need in the market, product in the market, we can use sentiment analysis to monitor that product's reviews. Sentiment analysis is also efficient to use when there is a large set of unstructured data and we want to classify that data by automatically tagging it. For example, we have Net Promoter Score that surveys widely utilized to acquire insights into how customers perceive a product or a service. So the increasing prominence of sentiment analysis is attributed to its capacity to efficiently handle extensive collection of NPS feedback. So we are collecting the NPS feedback and we are promptly yielding the reliable outcomes out there. So we can understand for a product that if it is satisfying the customer's needs or not. Let's understand some uses of NLP, like social media monitoring. The use case is like, for example, if a company tracks Twitter mentions to understand how people feel about their latest product release, a song, or anything. So sentiment analysis will reveal that the majority of tweets are positive, with users praising the product's feature and design. This is how we will use sentiment analysis for social media monitoring. This is one of the top examples of sentiment analysis. Next, we have customer reviews. The use case is, for example, there's an e-commerce platform like Amazon, Flipkart, or anything, and it will analyze the customer reviews of a new gadget. So we will get to know as an outcome that the result is a positive, negative, or neutral, or it will help the potential buyers to understand if the product is viable or not, if it's worth the money or not. So how they will do it? They will do it they will make informed decisions based on others' experiences. Next, we have movie recommendations. So the use case is a streaming service uses sentiment analysis to suggest movies to users. For example, if you're watching a comedy movie on Netflix, you will be getting a recommendation of comedy movies on Netflix, or movies that will have similar actors and actresses from your previous movies. This is how movie recommendation systems work. Well, the system is actually quite complicated itself, the model is, but we can understand it by some simple examples like this. So, by analyzing the user reviews and ratings and the service recommends So by analyzing the user reviews and ratings, the service recommends films that match a user's preferred sentiment, like suggesting feel-good movies for users who prefer positive content. This is how sentiment analysis actually works. Next, we have projects. So sentiment analysis has some really amazing projects like fine grained sentiment analysis, emotion detection, aspect based sentiment analysis, multilingual sentiment analysis, and there are so many more projects available on Project Pro. Let's look at one of them. We have just understood what sentiment analysis means, and now it's time for the project. Project Pro again brings you amazing project on sentiment analysis, that is many to one LSTM for sentiment analysis and text generation. This will help you understand how sentiment analysis works. You will understand how to convert text into a numerical representation using the bag of words technique, that will understand in future. You'll also create your own models and stuff. You can start your project whenever you want. If you want some more projects, you can just search up for them, and this project can be one of the point of view changing project for sentiment analysis for you. Next, we have amazing topic, and that is topic modeling. What is topic modeling? Topic modeling, we can understand it is a machine learning technique that automatically analyzes text data to determine cluster words for a set of documents. Confusing? We can say with topic modeling, it can understand whether anything is what kind of data, and it will cluster the similar amount of data in a specific way that we will call topics, like this. So it is just known as unsupervised machine learning because it doesn't require a predefined list of tags or training data that's been previously classified by humans. So since topic modeling doesn't require uh, training, it is quick and easy way to start analyzing our data into a simpler way than other models. So some really interesting examples of topic modeling are given here. Before understanding these two topics, we will go through two common words, which are topic modeling and topic classification. Topic modeling doesn't require training, so it is quick and easy way to start analyzing our data. However, we can guarantee that we will receive accurate results, which is why many businesses opt to invest time and training in topic classification models. So, since topic classification models require training, they are known as supervised machine learning. So, topic classification is supervised machine learning. They are SL, and topic modeling is unsupervised machine learning, UL. And what does this mean, being supervised and being unsupervised? Well, we know what supervised and unsupervised mean, but we mean that opposed to the text modeling, topic classification needs to know the topics of a set of text before analyzing them. Using these topics, data is tagged manually so that a topic classifier can learn and later make predictions by itself. Let's look at an example. So the line we have here is the nice thing about our brand. This is a review for Eventbrite. This is a review for Eventbrite, and we are looking at it. So in this one, what topic modeling is doing is by identifying the words. It is identifying the words like free to use, charging, fee, charging again, 2.5 percentage plus a $0.99 transaction fee. By analyzing these words, topic modeling can group this review with other reviews that talk about similar things. This may or may not be about pricing. Like, it's not mandatory for it to be about pricing. Now let's take a survey for a review about Survey Monkey, for example. So we have this review for Survey Monkey, and we'll see the supervised learning based topic classification here. See, topic classification models that has been trained to understand these expressions like gold level plan and love the features, the best bang for luck, for buck. This all words would be able to tag this review as topics, features, and price. So TC, topic classification, will do what? It will mark all this bolded text into its features and price. So in short, topic modeling algorithms churn out collections of expressions and words that it thinks are related, leaving us to figure out what these relations mean. While topic classification delivers neatly packaged topics with labels such as price and features, eliminating any guesswork. So what we are going to use in future is more of topic classification rather than topic modeling. But we need to understand how topic modeling works before going into topic classification. We have understood what topic modeling is, and now it's time for the project again. Project Pro gives you this project called NLP project on LDA topic modeling Python using raised dataset. You'll be working with a raised dataset and you will be doing all this thing in Python. You will actually create your own topic modeling. You will actually understand what topic modeling and cleaning is. You know how and what kind of text cleaning needs to be done. You will understood a lot of things, and later on you will create your own model based on that. You will again get your architecture diagram. Architecture diagram will help you holistically while working on a project. You will know the flow of your data, and then you can get all the profits Project Pro provides you. So it's high time that you should go to Project Pro and explore this amazing project. Next, we have word embeddings. What a word embedding? It's like word vector. It is like a special way of showing words and what they mean. It turns words into numbers like a secret code to put them in a similar space. This way, words that mean similar things are shown in a similar way. So imagine thinking of a word having 50 numbers. 50 numbers. What will be there? A word vector with 50 values can represent 50 unique features. Uh, like it's like something like age. If it's related to sports, fitness, employment, and more, like we can say 50 values, 50 unique. Anything that relates words to another. For example, age, sports, fitness, all employed, all these things are like can relate to each other on some level. So each word vector has values that is corresponding to these specific features. Let's understand word embeddings more properly. What is the goal of word embeddings? It is to reduce dimensionality. It is to use a word to predict the words around it. We are going to use a single word like a queen and predict what can be around this word, and interword semantics must be captured. We will graph the words in a specific way, and we will give each word like queen, king, apple, banana a specific vector, a specific type, a specific number. But there are also drawbacks of word embedding. What? It can be memory extensive. We are creating vectors, we are giving it numbers, we are saving it somewhere. So all of these things are going to be drawbacks and it will take memory. So this is going to be memory intensive. Then the corpus dependent, and it is corpus dependent. That means it will need two types of data. Any underlying bias will have effect on your model. So if we are feeding it two types of data, and what two types of data are different every time, then this will also affect the quality of model. A different model can be created by giving different types of data. Then it cannot distinguish between homophones like break, break, cell, cell, weather, etc. Cannot distinguish. So these are some drawbacks of word embeddings that we will understand later on how we will overcome them. Let's understand some implementations of word embeddings. So word embeddings are methods of extracting features out of text. We are trying to extract the features out of text, but this time not just name and stuff. We are going to delve more into it so that we can input those features into a ML model to work with the text data. Next is like we are trying to preserve the syntactical and semantic information. We are not trying to break the information and give something else. So how to do that? To do that, the methods such as goal of words, bow, and the counter vectorization and TF-IDF, they all rely on a word count in a sentence, but they do not save any syntactical semantic information. So in these algorithms, what happens is that the size of the vector is the number of elements in the vocabulary. So if there are three elements like shut the door, so the size of the vector is also going to be 3, something like 3 by 3. And we can get a sparse matrix if most of the elements are 0. Large input vectors will mean a huge number of weight, which will result in high consumption computation required for training. And with high computation, we also know that it requires memory as well. It is memory intensive. So word embeddings give a solution to these problems. How? Let's see. The very first technique of word embedding we have right here is word to vec. In word to vec, every word is assigned a vector, and we start with either a random vector or one hot vector. Now, what is one hot vector? One hot vector is sort of a form of representation in which only one bit in the vector is set to 1. For instance, if there are 500 words in a corpus, then the vector length will be 500. Once we have assigned vectors to each and every word, we choose a window size and we iterate through the entire corpus. And while we do this, there are two neural embedding methods which are used. Let's understand these two neural embedding methods. The first is SIBO and second is skipgram. Continuous bag of words. What is SIBO? In this model, what we do is we try to fit the neighboring words in the window of the central words. We are getting input multiple words right here, and we are trying to put all of them into a central word. We are not translating or changing them. We are trying to find a central word around this or other words. This is called continuous bowl of words. This is how it works. And the next one, so in a nutshell, we can say SIBO works by trying to fit the neighboring words in the window to the central word by making it a valuable technique for understanding the meaning of words in a context. Next, we have skipgram. Skipgram, in this model, we try to make the central word closer to the neighboring words. If it is complete opposite of the SIBO model. See, last one we were trying to find a central word for a lot of words that have been input. Here we have one input word and we are trying to find the central words around it. So this skipgram and SIBO are completely opposite of each other. So it is shown that this method produces more meaningful embeddings. Yeah, we have realized with further understanding that this model produces more meaningful embeddings because we are trying to guess from a single word what can be the other words around it. Why it produces more meaningful embeddings? That is because it captures the context and relationships between words efficiently. In skipgram, the central word is like the star of the show. This is the star of the show, and we are trying to understand it better by examining its neighbors. Next, we have gloves. This is the second technique for a word embedding. Now, this is another method. See, GLOVE. First of all, GLOVE stands for Global Vectors for World Representation. Global Vectors for Word Representation. It is another way to make word embeddings. How it works? So we start with bunch of text like this, and it is like a collection, a bunch of text which we will call a corpus, and it is like collection of sentences. So we can go through the corpus and count how often each word shows up near other words. That is called co-occurrence. Like it is near a how many times or how many differences is between these two words. Based on these counts, we can create a special matrix that shows how likely words are to be near each other. If two words are right next to each other, they get a high value like 1. If they are one word apart, it is a bit less, like 1.5. If they are two words apart, it is like 1 by 3, and so on. So if they are just next to each other, they will get 1. If they are one word apart, they will get half. And if they are two words apart, they will get 1 by 3, and so on. Let's see how the matrix works. So it and it is not around each other, so we'll give it a 0. Is and it are just beside each other. See, is and it are just beside each other. For example, also, so it and is are getting 1 plus 1. Now it and a are not exactly beside each other. They have one number in between, that is is. So if they are one word apart, they will get 1 by 2. We have just read it. So they are getting 1 by 2 as a number. So we can see that the upper half of the matrix will be a reflection of the lower half. So upper half of the matrix is staying like this. The dimensional, the diagonal is going to be 0, and we can consider a window frame as well to calculate the co-occurrences by shifting the frame till the end of the corpus. Now what we'll do, it will help us gather information. It will help us gather information about the context in which the word is used. So we'll do this many times. And after many iterations of this process that we have just discussed, we will get a vector space like this. We will get a vector space presentation, and that will approximate the information for the co-occurrence matrix. This is our co-occurrence matrix. So the performance of Glove that we have just understood is better than word-to-wake in terms of both semantic and syntactic capturing, because word-to-wake does not capture semantic and syntactic information, but Glove does. We are back with one amazing project based on word embedding, which is multi-class text classification with deep learning using BERT. We will again be working with BERT model because this is highly one of the used and preferred model out there, and we will understand how word embeddings actually work, how we'll create vectors and stuff over there. So we'll be working with the bag of words, bow, and TF-IDF models that we discussed. Word to wake, globe, and fast text models. We will also be understanding how they work. These are word embedding techniques. We will be understanding the RNN and LSTM models, which are one of the most important models out there. We will be creating our own model, importing data from Hugging Face library. We'll do a lot of stuff. We'll also learn how to save the model. We'll actually create our own BERT model. At the end, as usual, you will get your architectural diagram to understand the flow of your data, and after that, you can just doubt if you occur for any, you can ask for your mentor on one-on-one live sessions and start your project whenever you want. Having such sort of projects in your resume will make your resume shine like none other. It will make your resume stand out in between other resumes sending out there. They will know that you have done more in machine learning and such topics in NLP, and you have not just explored the surface level or the eyes of the tick-bug, you have actually gone deeper. This will actually improve your understanding of natural language processing and will make sure that you understand not just the theory but also practical of such topics. So do check them out. As a conclusion, to wrap things up, we can say that natural language processing or NLP is like teaching computers to speak our language. It is a captivating field with techniques and cool applications like understanding text, what it means. We encode it, we give it to a machine learning model, we predict it, we decode it again. So in today's digital world, NLP is like engine powering chatbots, virtual assistant, and all things related to language on the internet. Now here at Project Pro, we have got a treasure of trove of NLP projects. Whether you are just starting or you are an NLP pro, our projects are hands-on and ready for you to explore the amazing world of NLP. Thanks for tuning in, and we can't wait to join you on your NLP adventure. Thank you.